Hello guys, welcome to today's video. And in today's video, we are going to start with very important topic, a graph of a polynomial. Okay, so let's get started. When we talk about sketching graph of a polynomial, our main requirement is the plane, right? The plane on which we are going to sketch or draw the graph of any polynomial. Before we start making the graphs for different polynomials, let's take a look at the plane on which we are going to do all of these things. Okay, so we use xy plane or Cartesian plane to sketch the polynomial graphs. Okay, just for your notes purpose, if you are maintaining the notes, you can write it down. Okay, so graphs of a polynomial or graph of any polynomial is made, you can write here, graph of a polynomial function is made on we call it xy plane or Cartesian plane, Plane. Okay, so graph of any polynomial is made on xy plane. We call it xy plane or Cartesian plane. Both are same. Okay, now why is it called Cartesian plane? Okay, why is it called Cartesian plane? Because it is named after a famous mathematician, French mathematician, René Descartes. Okay, René Descartes, he's also known as father of coordinate geometry, right? So the reason why this plane is known as Cartesian plane because it is named after René Descartes, a French mathematician. Okay, then if you want me to write the name, okay, I can write here Cartesian plane is named after René Descartes. René Descartes. Okay, French mathematician, also known as father of coordinate geometry. Okay, then on this xy plane or Cartesian plane, when we draw graph of any polynomial, then our end product is going to be something, right? So the end product that we get, okay, after doing all the things on this xy plane or Cartesian plane is known as a curve. Okay, curve. So curve. Okay, so curve. If I have to define curve, I can define curve as a curved line that changes its direction at least once. Okay, I can define curve as what? A curved line, a curved line that that changes its direction at least once. Okay, at least once. Okay, at least once. See here, for example, you can take any curve. For example, parabola is a curve. Okay, so when we design parabola, or when we sketch a graph of parabola, it goes like this: parabola. Okay, so now see here, if you look at this curve, okay, what is it? It's a curved line that changes its direction at least once. Okay, understand? Got my point? Okay, so that's the definition of a curve. Okay, now there are some more things that we need to understand about your Cartesian plane or your XY plane, okay, because we are going to use those things. So later on, I don't want to come back and explain the things, okay? So now the main thing is that what is Cartesian plane or what is XY plane, okay? So if I have to define Cartesian plane, I can say that a Cartesian plane, okay, a Cartesian plane is formed by two perpendicular number line system, okay? Uh, See here, this is Cartesian plane. What is it? Okay, so here I'm just writing formed by two perpendicular number lines, right? Number lines crossing each other at O origin. Okay, so please keep this thing in mind. If someone asks you what is Cartesian plane, just tell them that it is defined by two perpendicular number line system. Now see here, number line system, what does it mean? Okay, so here I have this 0, here plus 1, here 2, here 3, here 4, here 5, so on up to infinity. Here minus 1, minus 2, minus 3, minus 4, minus 5, so on up to minus infinity. Okay, and then here I have the vertical one, okay, and this is 1, 2, 3, 4, 5, so on up to infinity. This is minus 1, minus 2, minus 3, minus 4, minus 5, so on up to minus infinity. Okay, so Cartesian plane is formed by two perpendicular number line system. What are these? These are basically number lines, right? And they cross each other at point O, and O means origin. Okay, so this O is origin. Now I hope this point is clear to you. Now it is formed by two perpendicular lines, so horizontal line. So the horizontal one, we call it x-axis, okay, and the vertical one, y axis. Okay, if you don't know, you can say the horizontal axis, horizontal horizontal line. This is x axis, and vertical line is y axis. Okay, vertical line is y axis. Now my next question is that what do we use it for? Okay, we defined Cartesian plane, but what's its use? Okay, so the use it describes. Now see here what happened. It describes, okay, it describes the position of any point in the plane. Okay, for example, if my point is here, it will describe the position of point in the plane using the ordered pair of numbers. Okay, so see here, you will understand it. It describes the 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 position of any point in xy plane or Cartesian plane. What does it mean, any point? Okay, position of any point. This thing is important. Now see here, how does it describes the position of any point in xy plane? So because the Cartesian plane or xy plane, it uses ordered pair of numbers in the form of a comma b, written within the brackets separated by comma sign. Understand? So this is ordered pair of numbers. Okay, what does it mean, ordered pair of numbers? Okay, it means the numbers written within the parentheses separated by the comma sign, and it follows the particular order. Okay, this is very important. It follows, it has particular order. Okay, what does it mean? It means if it is written as a and if it is written as a comma b, then you cannot use it as b comma a. Understand? So it has a particular order. It defines the particular order. You cannot change the order. Okay, so that's what ordered pair of number means. I hope this thing is clear. Now, uh, here within the parentheses, two numbers are written, right? Two numbers are written. So A represents. Okay, now see here, this number A. Okay, what does A mean? A represents. A represents. A represents x coordinate, x intercept. A represent x coordinate, okay, or x intercept, or 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 abscissa. Okay, so whenever you see these three things, whenever you see this ordered pair of number, the first number represents your x coordinate, or you can call it x-intercept, or you can call it abscissa. Okay, then this b. Okay, now see here, b represents y coordinate, y coordinate or y intercept or ordinates. Okay, so B represents your y coordinate or y intercept or ordinate. Okay, so this is the meaning of x and y coordinate. Okay, if you are making notes, then these things are important to you. Okay, if you are making notes, the reason why I'm doing this, because I know that there are lots of students who would like to maintain the notes. Okay, now see here, we understand it, it's x-intercept, it's y-intercept, it's abscissa, it's ordinate, but what does it mean? Now see here, when you see any point, okay, for example, let's take a point 3 2. Okay, this is a point, 3 2, 3 comma 2, this is a point 3 comma 2. This is a point 3 comma 2 on this plane, xy plane. Okay, now 3, what does 3 represent? Sorry, this is 3 comma 2 here, this is 3 comma 2. Okay, what does this 3 represent? Now 3 represent the measure of distance of this point from origin. Means this is going to be 3 units. Why? Because if you see this, so the distance of this point from the center is same as this, okay, which is 3 units. Okay, so this is going to be my 3 units, and 2 represents the distance of this point, okay, this point in vertical direction from the center. So this is going to be my 2 units. Okay, so I hope this thing is clear. Okay, so this all was the basic of your Cartesian planes. There is one more thing. Okay, there is one more thing. uh, in Cartesian plane, sometimes, not sometimes, but most of the, not every time, we make a table known as a coordinate table. Okay, coordinate table, coordinate table. Okay, what does that mean, coordinate table? Okay, so we maintain one table. It's like an ordinary table where, for example, this one here, I make a table. Okay, here I will write x, here I will write y. Okay, because whenever we draw something on this plane, we have two variables, right? We have two variables, okay, independent and dependent. Okay, so it can be y or it can be px, it can be fx, the meaning is the same. Okay, so see here, when you will put when you will put any value of x here, you will get some value of y. Okay, so we just keep on maintaining this table so that we can collect different values of x and y from here, and we can locate all those points on the Cartesian plane. Okay, and in the end, what is curve? A curve is made by connecting all these points and tracing them. Okay, so I hope things are clear. Okay, if not, then when we'll do the questions, it will become more clear. Okay, so let's start with a graph of a polynomial, because we have different types of polynomials. So we'll start first with 0 degree polynomial, constant polynomial. All right, so okay, graph of polynomial, we'll start with constant polynomial. Okay, before we start graph of the polynomials, okay, fine. We just have to know a few things, okay, because those things are very important to sketch the graphs. Okay, so whenever we want to draw or sketch the graph of any polynomial, we need to know three things. Okay, I will write it here: and behavior, and behavior, and behavior, number one. Then the second thing is zeros, zeros, and the third thing is multiplicity, multiplicity. Okay, and is something left? Uh, now we done, right? So three things are very important to sketch any polynomial graph. Okay, so we'll start with your first degree polynomial, because see here, I will just talk uh, about this constant polynomial. I will just, describe it in a very simple way. Okay, so just try to understand. Okay, because px equal to k, this is constant polynomial because it is of 0 degree. For example, px equal to 7. Okay, now see here, this is independent of x. Okay, it just has a constant value. Okay, so if I say, because this px, when I design its graph, see here, this is x-axis, this is x-axis, and here this is y-axis. Okay, y-axis, or here I will write it y. You can also write px if you want. Okay, so here 1, 2, 3, 4, 5, 6, 7. Okay, on this side -1, -2, -3, -4, -4, -5, -6, -7. Okay, so on minus infinity, here infinity, here 1, 2, 3, 4, 5, 6, minus, minus, here 1, 2, 3, 4, 5, 6. Okay, so px equal to 7 means y equal to 7. Okay, if you will, y equal to 7. So if you will draw the graph of this constant polynomial, it's going to be the horizontal line parallel to the x-axis. This is this is y, this is y equal to 7. Okay, y is equal to 7. Y is equal to 7. Now see here, this is a horizontal line. We don't talk much about constant polynomial or sketching graph for constant polynomial, because this polynomial has no zeros. Okay, because zeros does not exist. Now see here, when zeros exist, what happen? When zero exists, the graph will cut or touch the x-axis and make x-intercept there. Okay, so always remember, when zeros are formed, how they are formed. When zeros are formed, graph touches or passes through x-axis. Okay, but here zeros, they don't exist. Why? Because our graph is horizontal line. Okay, now see here, so we spoke about these three factors. Now what is end behavior? End behavior means that from where, okay, the directions of the graph. End behavior means where it will go. Okay, will it rise up, will it go down? Okay, so and behavior, and behavior means rise up or go down. Okay, it tells us the direction of the curve. Okay, what's going to be the behavior of the curve? Is it going to rise up, or is it going to go down? Okay, so end behavior. Okay, we will come to multiplicity when we'll start with the next type. Okay, so here always remember we do not have any zeros, and the graph is always a um, graph is always a straight line. Okay, straight line. Now, sometimes you may, because see here, this is the graph for y is equal to px. Okay, px. Okay, and px, it was a constant value, so y is equal to 7, right? Now, this is the graph of y equal to 7. If someone asks you what's going to be the, so wait, if someone asks you what is going to be the graph of y less than 7, okay, y less than 7. Okay, so y less than 7 means y less than px. Okay, y less than px. Okay, so in this case y less than px means it will cover this area. Okay, and y less than px, this is y equal to px. Okay, so can I write y less than px means region below y equal to px, and 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 it does not include the line or the curve. Okay, uh, curve curve not included, not included. Okay, so I'm talking about this region, but this line is not included. Okay, now what is y greater than px? Okay, y is greater than px. Y greater than px means this area. Okay, the area above the region, sorry, the region above, the region above the curve. Okay, region above y equal to px, curve not included, curve not included. If someone asks you y less than equal to px, then it's same, but curve is included, curve is included. Or if someone asks you y is greater than equal to px, same, region above, but curve included, curve is included. Because I just want to make sure that you understand how to sketch the graph, and then you can also sketch, or you also know, if they give you inequalities and you have to find the region, so you must know how to do that. Okay, so y greater than px in horizontal above, less than px below, uh, curve not included, greater than equal to above, curve included, less than equal to below, curve included. Okay, so that's all about this this what constant polynomial graph. Okay, constant polynomial graph. Okay, So if they give you a draw graph for px equal to 10 or px equal to 5 or px equal to 2, every time it's going to be the straight line. Okay, straight line, horizontal line. Okay, so I hope it is clear. Okay, now let's go to the linear. To the let's go to the linear. Let's go to the linear polynomial. Okay, let's go to the linear. Okay, let's go to the number 2 linear polynomial. Okay, yes, I need 4 things here. Number 4 is the co coordinates table. Okay, I will make it here. X, Y. Okay, now we will make use of it. Now, linear polynomial. First of all, what are linear polynomials? They are represented by px equal to ax plus b, where a must not be equal to 0, a be real numbers. Okay, a be real numbers, and uh, how many zeros do we have for linear polynomial? Only 1 0. Okay, so let's see how to sketch the graph of any linear polynomial. Okay, any linear polynomial. This is 1, okay, this is 2, this is 4, this is 6, this is 8, this is 10, this is 12. Okay, and here this is -2, -4, -6, -8, -10, -12. This side is minus infinity, this side is positive infinity. This side, okay, on this axis, this is +2, +4, +6, +8, +10, 12, 14, 16 here, -2 here, -4, -6, -8, -10, -12, -14, -16. Okay, so on here, this side infinity, this side minus infinity. Okay, now let's take an example. For example, we have to draw the graph of px equal to, okay, px equal to 3x plus 1. Okay, and px, this is one example. Another is px equal to x plus 5. Okay, x plus 5, or okay, x plus 5, it's fine. Okay, now let's start with number 2 first, because number 2, because number 2 is easier than number 1. Okay, so I'm going to do number 2 first. Okay, so it says that px is equal to x plus 5, right? Px is equal to x plus 5. Now I can represent this px by y, so I can write y is equal to x plus 5. Okay, so this is going to be my main polynomial function. Okay, now see here, the first thing that we need to do when we sketch the graph of linear or degree 1 or higher degree polynomial is we have to check the end behavior. Okay, we have to check the end behavior, means we need to see what direction the curve is going to follow. Okay, so once the directions are clear, then it becomes a piece of cake to sketch the graph. Okay, now to do that, what we do is, so now see here, what we need to do is this equation, can I write from here y is equal to x, and here 1 plus 5 by x. I hope you got it. Nothing, just I took the x common and this came. Okay, now checking end behavior. Okay, now I have to check end behavior. Okay, end behavior, checking end behavior. This is going to be my number one, step one. So I will check if x behaves something, that how that is going to affect the behavior of y. Okay, let's see if x is infinity. Okay, if x is infinity, positive infinity. Okay, if x is positive infinity, then y is going to be positive infinity, because here 5 by infinity is almost 0, so infinity, positive infinity, right? Then if x is minus infinity, okay, if x is minus infinity, so here minus infinity, 5 by minus infinity, almost 0, then I can say y will also tend towards minus infinity. Okay, now come here. This is your x-axis, this is your y. Okay, so if x infinity, y is infinity. If x is infinity, y is infinity, means this side, means this side, right? And if x is minus infinity, y is minus infinity, means this side. So it means your curve is going to be like this. Okay, it's going to be like this. Okay, so let's see if that is true or not. Okay, so end behavior, we check the behavior of y according to behavior of x. Okay, but here what they say that end behavior is checked by the leading coefficient, leading coefficient a. And it says that if a is greater than 0, then end behavior means rise up. If a is greater than 0, then rise up. Okay, but our way of finding the end behavior, we are not interested in looking at the 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 sign of a. Okay, if a is greater than 0 means positive, if a is negative. Okay, we are more interested in finding out, like, why does it happen. Okay, so you have to check behavior using this. Okay, you can do it either way. Okay, or it says that if a is negative, then goes down. Okay, we can check it later for different graphs. Okay, so that's not a problem. Okay, so this is sure. Okay, now End behavior is done. Now we know the end behavior, then we go to the next step. Okay, we go to the next step. The next step, is step 2. Step 2 means zeros. We have to find zeros. Now this is a linear expression, y equal to x plus 5 linear equation. Okay, if I have to find the zero of this polynomial function, what do I have to do? Zero means the value of x for which px or y becomes zero. So I can say x plus 5 equal to 0 means x equal to minus 5. So see here, this is 0, right? The value of x or the solution means 0. Okay, the value of x is 0. Okay, so here zeros are found, means minus 5. So I can minus 5, it's going to be here. Okay, so this point I can say minus 5 0. Okay, minus 5 0. So my step number 2 is done, because linear polynomial has only 1 0. That 0 is minus 5. So step number 2 is finished. Now number 3 is multiplicity. Multiplicity of 0. Now if I have to represent this 0 in the expression form, this number in the expression form, it will become x minus 5. Okay, x minus 5. So multiplicity refers to x. If alpha is the 0, then if the zeros, okay, if the zeros comes in the expression form and it is of the form x minus alpha raised to the exponent k, then k represents the multiplicity. K represents multi multi multiplicity. Okay, k represents multiplicity. Okay, so let me just shift it up. Number 3, multiplicity. Okay, so multiplicity of 0 is represented by x minus alpha k. K represents multiplicity. Okay, k represents multiplicity. What does it mean? It means the exponent of the factored form of 0. Okay, the exponent of factor form of 0. Okay, so if k is odd, then pass through. K is odd means that if your multiplicity is odd, then the curve will pass through the x-intercept. Okay, if k is odd, curve will pass through x-intercept. Okay, and if k is even, touches and bounce over. What does it mean? See here, example. Okay, I'm just giving you an example. Okay, the example is not related to this question, it is just to make things clear for you. Okay, for example, I have I have this okay, let's take this polynomial expression x plus 5. Okay, now see here, because step number 2, the 0 was minus 5, and when I write it in the factor form, multiplicity, then when I write it in the factor form, it becomes x plus 5 raised to the exponent 1, right? Because x plus 5, and here it was nothing, so it means raised to the exponent 1. It means your multiplicity is odd. So when your multiplicity is odd, it means whatever your curve is going to be, it will pass through or cut the x-axis at this point. Okay, if, for example, if your multiplicity means if I have this quadratic polynomial and my zeros are in the expression form like this, x minus 5 0, so it means the value of x is 5 1 2 3 4 5. In this case, what will happen? Multiplicity is even, so it will not cut, it will bounce. Bounce means it will bounce over, it will bounce over on this point. Okay, but if it is if it is odd, if it is odd, for example, if at 5 0, if it is odd means if it is x minus 5, then your curve will go like this. It will pass through, okay, it will pass through the x-axis. I hope it is clear to you. Okay, now let's come to the point. So this is the 0, and the 0 has what multiplicity? Odd. Odd means it will pass through the x-intercept. Okay, it will pass through the x-axis. Now step number 4. Now come to step number 4. We have to do 4 steps. Okay, step number 4 is we checked multiplicity. Now step number 4, we have to maintain the coordinate table. Okay, this is x, y, so that we have more coordinates and it's easier for us to trace the located points. Okay, I have this here minus 5 0 because here this is the 0. And then can I check for if I put value of x 0, then this is y equal to x plus 5. So if I put x 0, y will be 5. Okay, and if I put y 0, if I put y 0, x will be minus 5, that is the 0. Okay, if I put 1, y will be 6. If I put minus 1, then y will be 4. If I put 2, y will be 7. If I put minus 2, then y will be 3. If I put x equal to if I put x equal to 4, 5, x 5, y 10, minus 5 0, that's fine. Minus 6, x minus 6, then y is going to be minus 1. Okay, now let's locate the points. Okay, so x 0, y 5, x 0, y 5. So this is going to be the point, the value of 5. Here x 0, y 5. Next, x1, y6, x1, y6. This is going to be the point. 1, 6. Then minus 1, 4, x minus 1, y minus 1, x minus 1, y 4. This point. Sorry. This point. Minus 1, 4. Then x2, y7, x2, y7. This point. here 2 7, then x minus 2y3, x minus 2 y 3 3, this point minus 2 3, then x5 y10, x5 y10, this point 5 10, okay, then x minus 6 and y minus 1, this point y minus 1, this point, okay. Now see here, if we try to join all the points, if you try to join all these points, you will get a straight line. You will get a straight line. Okay. Why? Because end behavior was rising up. Okay. So the end behavior, we already found the end behavior for this. Okay. So that's what the graph looks. Okay. Now see here, it has only one zero. So 0 is the point x-intercept where the graph cuts the x-axis. If any polynomial has 2 0, it means the curve will cut the x-axis 2 times. Understand? If 3 zeros, 3 times. Okay? So I hope this thing is clear. Now, see here, this is the curve for y equal to fx, right? If someone asks you y greater than fx, show us the region, right? Y is greater than fx means this region, this region, but curve not included. Okay, if y is greater than equal to fx, again this region but curve included. Okay, y less than fx, then this region, okay, but curve not included. But if y less than equal to fx, then again this region but curve included. I hope I'm making sense to you. Okay, now let's take one more case. Okay, let's take one more case of the same question. Okay, let's take one more case of the same question. We are just going to change the condition. Okay, so see here, now we will do it for here x plus 5. Now we will do it for minus x plus 5, minus x plus 5. Now here minus, and inside same, right? Now see here, step number one, end behavior, okay, end behavior, x infinity. If x is infinity, then what will happen? This 0, right, and infinity multiplied by 1, sorry, minus infinity, so y will be minus infinity, right? If x approaches towards minus infinity, then this will become infinity. Why? Because minus of minus infinity, positive infinity, this is 1, plus 5 by minus infinity, it is 0, so infinity. Okay, now see here, check the end behavior on the graph. X infinity, y minus infinity, x infinity, y minus infinity means here. and x minus infinity, y infinity, x minus infinity, y infinity means this side. So your graph is going to be this, okay? This means going down, okay? So why? See here, that's what they say when your a is less than 0. Now see here, if I multiply it inside minus sign, then my coefficient, leading coefficient becomes negative. So the graph or the end behavior will go down, okay? The end behavior is going to be not rise up, goes down, okay? So the end behavior is checked, fine. Then next thing is we have to check zeros. Number 2, zeros. Now for zeros, what we need to do, we have to equate minus x plus 5 equal to 0. Okay, so it will be x equal to minus 5, right? Yes or no? X equal to minus 5. Then it means x plus multiplicity, number 3. Number 3 is multiplicity. Okay, step number 3, multiplicity. So it's going to be x plus 5. Here 1 means it means passes through x axis, okay? And number 4, coordinate table, x, y. So y is equal to minus x plus 5, y is equal to minus x plus 5, okay? So if x0, y minus 5, okay? If x1, y would be minus 6. If x2, y would be minus 7. If x minus 1, then minus 1, minus 4. Minus 2x, then minus 3. Okay, let's see what points we are going to get. Okay, so x0, y5. First of all, where is going to be, so this is again going to be x equal to minus 5. So this is going to be our 0. This is going to be our 0. Okay, this is going to be the 0. So this point is minus 5, 0. Sorry, 0, minus 5. 0, this point is going to be, this point is going to be minus 5, 0, right? If you put x0, y will be 5. If you put x0, y will be 5, means this point. Okay. If you put x1, y would be minus 6. x1, y will be x1, y will be minus 6. If you put x1, y will be minus 6. Y, x minus 5, yes, minus 5, and minus 1, then minus 6. So if x is 1, y is going to be minus 6, means this point. Okay, if x is 2, y minus 7. If x2, y minus 7. 2 minus 7 means this point. What point is this? X0, x0, y minus 5. X0, y minus 5. This point. Okay, this was mistake. And if x minus 1, y minus 4, x minus 1, minus 1 here, y minus 4, this point. Okay, and this is going to be the 0. So if you trace minus 2, minus 3, x minus 2, this is going to be minus 3 around here. Okay, so if you trace all these points, see here, all these points, it's going to be if you trace all these points, you are going to get the straight line like this. Okay, so see here, in previous question, just by changing the sign, you can see that how it has affected the behavior of the graph. Okay, again same thing. So this is y equal to y equal to px, right? So if you want to if you want to find for y greater than px, then it means this region, understand, but this line or curve not included. Y is next, number 2, y is greater than equal to px, again the same region, okay, above this, but the line is included. Then number 3, y less than px means region below this, okay, but curve not included. And number 4, y is less than equal to px, again the same region below the curve, but curve is included. Okay, so I hope we are discussing the inequalities too, okay, so that later on we do not need to create separate